by Kaylee Rainier Brown. It says Obex Risk, but she's actually coming from her new office. It's her second day at her new job, and she is the lead engineer for industrial process safety at Jensen Hughes in Halifax. So I would like to congratulate Kaylee on her new position. And just so everybody knows, she hasn't gone away. We are still going to be working with Kaylee. So I'll leave that with everybody. So way you go, Kaylee.
Thanks a lot, Bill. Yeah, apparently you're still stuck with me according to Bill. So I'm very, very happy to be here with you guys today. Always love sharing some of the good work that I'm undertaking with Bill and the team at the BC4 Safety Council and in the wood products manufacturing industry. So this is building on a topic that we've been working on now for a couple of years. So something of a significant risk to the wood products manufacturing industry, and that's mobile equipment, primarily focusing on the mobile equipment pedestrian interface. So really looking at preventing struck by incidents, which all of you are well acquainted with at this point in terms of the magnitude, severity, as well as the likelihood of injury. I think what we've seen throughout a number of workshops, through discussions with others, is that it's very easy to actually kind of underestimate the risk of mobile equipment. Whether it's forklifts, even just personal vehicles on site. It's certainly an insidious hazard. So just excited to take you guys through some of the work that we've been undertaking, kind of where we started, which was a hazard analysis with the sawmills, and how we kind of expanded on that work into some research completed through an applied innovation grant under WorkSafe BC. So that's primarily what the topic of today's webinar will be kind of some of the key outcomes and findings from that. And the technical report will be available Q4 of this year. Certainly hope to have it out to everyone by the new year. So without further ado, let's dive into it. So like I mentioned, the ongoing research grant that we've been working on. So kind of the two main aspects of that is bow tie analysis and inherently safer design. And we'll do a bit of a deeper dive into those topics and kind of how they apply, and really just, underscore some of the fundamentals for that in case those tools and those concepts are new to the folks on the call. And then again, two kind of outcomes so far from the research grant has been some ways to engage workers on how to reduce mobile equipment risk. And that's an inherently safer design review. And that really just involves some brainstorming questions. So I'm going to share those with you guys today. And then how to engage leadership, because we know that a lot of this changes with respect to the way that we handle mobile equipment risk, and ideas around risk tolerance and really the safety culture around mobile equipment risk that involves engaging leadership. So one of the kind of tools and approaches that the researchers identified is an inherently safer design in management systems review. So it's a series of self-assessment questions, and again, when that full technical report is available, that self-assessment will be shared with you guys, so you can find a way to apply those concepts in your own operations. So yeah, I've been working with the wood products industry here in Canada for the past couple of years. Like Bill just mentioned, I just recently joined the Jensen Hughes team here in Halifax as a lead engineer in industrial process safety. I also am an adjunct with Future Metrics, or a pellet consultancy based in Maine in the United States. So again, very happy to be helping sawmills, wood pellet plants, and panel board manufacturing as well. Those who manufacture medium density fiberboard, oriented strand board, those types of facilities. I am a professional engineer registered in Halifax, or registered in Nova Scotia and British Columbia as well. So, like we kind of opened the presentation with, we know that mobile equipment poses a significant risk to personnel in facilities. Obviously, when you have struck by incidents and other scenarios involving mobile equipment, it can also include equipment damage or building damage if certain buildings and structures are getting hit. We also know that there's the risk of inventory tip over and collapse, and that can have kind of domino effects on personnel. We also know that mobile equipment and the operators running that equipment can experience ergonomic issues and musculoskeletal injuries as well, or MSIs. So mobile equipment, pedestrian interface struck by incidents, as well as MSI hazards, were included in WorkSafe BC's 2021-2023 manufacturing high-risk strategy. So again, kind of diving into the project background, I mentioned some work that the council and I completed on using bow tie analysis for mobile equipment hazards, specifically in sawmill applications. So this is just an example of one of the case studies that we worked through. So this is a sawmill, an overview of one, and you can see a couple of features. So the blue path is our designated walkways. We have stop signs at the beginnings of each of those designated walkways. We have storage areas where the main office is, where the kiln is, and its location with respect to the highway. So what we found in this area number 3 is this was a very high traffic area. And you have a great deal of, you have a designated walkway going right through it. So we completed, a bow tie analysis on sawmills like this one, and we identified, you have designated walkways, you have stop signs, you have safe work procedures if maintenance is being completed, if there's upset conditions in storage yards. But what we found was that currently, a lot of the risk reduction measures that we're relying on are administrative and procedural. So, relying on personal protective equipment, maybe those sounding devices that you would rely on personnel to wear and for, mobile equipment operators to hear if an interaction was nearby. So we know that procedural controls are the least effective and ultimately the least preferred because of that. So in an effort to, improve risk reduction strategies, we thought, how can we start to explicitly, have a dedicated and direct way to actually look at the way that, mobile equipment is moving on site, the configuration of sites and work processes, as well as where personnel are traveling. How can we actually look at that to see, can we actually do something different? And that really relies on inherently safer design. So we'll dive a bit more into inherently safer design, but really it revolves on addressing the hazards at the source rather than just adding on equipment and adding on procedures. So that was where the proposal to the WorkSafe BC Applied Innovation grant came in. And like I just said, the research project is based on identifying how to explicitly apply the 4 principles of inherently safer design, because we need to start addressing and considering how we can actually remove mobile equipment hazards as much as possible through design, rather than relying on more procedures and putting more burdens on personnel on site. So I've mentioned inherently safer design. And now we'll kind of go in a little bit more of how it fits into, all the different controls that we have at our disposal. So you're probably familiar with the hierarchy of controls here on the left-hand side, right? So your hierarchy of controls is your preferred order of risk reduction measures. So we have elimination and substitution at the top, followed by engineering controls, and lastly, administrative controls and PPE. So we just talked about, these are at the bottom of the pyramid and kind of make up the smallest part because those are what we want to be relying on the least. So I've mentioned inherently safer design. It's at the top of the hierarchy of controls. So this is the inherently safer design hierarchy of controls, and what we really use in process safety. We say, you know, ISD or inherently safer design, then passive engineered. So those are controls that don't require a computer to detect something and something to be activated. So a good example of that would be something like if you are, in your own sawmills or wood pellet plants, a spark detect deluge system would be an active engineered system. Passive engineered, that could be something like a corrosion resistant coating. You apply it and it performs without any further action or detection required. And again, administrative is at the bottom. So inherently safer design involves elimination and substitution that we have from the hierarchy of controls on the left-hand side. And like I mentioned, the engineering controls, we split between passive and active because there is a significant difference in the reliability, and really just the mechanism of it. So that's how we look at it in process safety. And then administrative controls and PPE are actually just captured as administrative controls, because ultimately where personnel would be wearing PPE, that's through a procedural measure. You have a policy that says thou shalt wear your high visibility vest when you are in certain locations, whether it's wherever you're on site or just certain areas. Same thing around, hard hats and hearing protection and glasses, so on and so forth. Let's dive into ISD a bit more. So inherently safer design, like I've said, it focuses on eliminating and treating hazards at the source rather than only relying on those engineering and administrative controls. So there are four principles. We've already touched on two of them. So minimization and substitution. So in the context of mobile equipment hazards, minimization could include redesigning a work area to minimize or eliminate the presence of pedestrians within the proximity of mobile equipment. Substitution, an example of that is, can we actually use a different process that would eliminate or minimize either pedestrians or mobile equipment in a given activity or area? We have two other principles of inherently safer design that we can leverage. So moderation is, really changing the conditions around the hazard in order to reduce the severity or likelihood of injuring of harm. So an example of this is relocating activities involving pedestrians actually away from mobile equipment. And lastly, simplification really starts to hinge on, the human kind of side of things. So can we actually redesign processes or work areas that would make it less likely for personnel to create a scenario that it would lead to a hazardous condition, whether it's due to an error or something around maintenance or operation. Bow tie analysis. This is the other kind of underlying key concept that we want to talk about. So it's a very visual hazard analysis tool, and it ultimately allows us to really comprehensively analyze how a hazardous event can occur, like a struck by incident or a musculoskeletal injury, and the measures that we need to have in place to either prevent that from happening, or if it were to happen, reduce the severity or likelihood of that. So I'll kind of go through each of the bow tie elements here. So the hazard is in the black and yellow box at the top square, and that's the scenario or the situation that has the potential to cause harm. So in this context, it's mobile equipment in, it was a sawmill, a wood pellet plant, general warehousing. So it hasn't harmed anyone yet, but there's the potential to be there. And then we would, describe what kind of a mobile equipment is actually within scope of the analysis. So it could be forklifts, chip trucks, it could be trains, depending on, your site, staff vehicles, contractor vehicles. You really get to decide what mobile equipment is of concern. The top event, like I mentioned, uh, could be an MSI, could be a struck by incident. Threats we have here on the left-hand side in the blue. So those are the scenarios or the conditions that have the potential to lead to that top event. So that could be an upset condition in a fiber yard where now you have mobile equipment operators coming in and out of their vehicle while there's other mobile equipment being moved. It could be unauthorized vehicles actually entering restricted zones. It could be contractors who are unfamiliar with the area or delivery truck drivers, all these different threats where they could present the potential of a struck by incident. Then we have consequences. So ultimately, unfortunately, the outcomes of a struck by incident typically, it's harm or death to personnel. And then we have other types of consequences related to business interruption. Uh, Depending on the context, it could be equipment damage as well or infrastructure damage. Again, kind of depending on the scenario. Then we'll go back to the left-hand side here. We have prevention barriers. So those are the measures that we need to have in place to actually prevent the top event from occurring. So again, that could be things like your personal protective equipment like high vis. It could be detection systems. It could be magnetic gates that are actually in place that are interlocked with equipment. So if there's mobile equipment passing by, the gate that a pedestrian would normally pass through won't actually open. It restricts access and controls access into that pathway. Another thing that we talked about a lot actually was looking at right of way. So, the concept that typically on industrial sites, um, the, you know, it's the mobile equipment that has the right of way, not the pedestrians, which is kind of the opposite, if you will, to everyday, you know, uh, street and roadway rules. So that was just something that we discussed as well, and it's something that's very heavily relied on, is yielding to mobile equipment. But we know that there's a lot of well, and I'll talk about those. So the degradation factors, that's one of the real strengths of bow tie analysis, is that we unfortunately know that these safety controls, these barriers are not 100% effective all the time. I just mentioned, something, the concept of the right of way and that policy that would be implemented on sites. But there's issues, you might have the policy, but even at that, are personnel actually aware that mobile equipment is in the area? Maybe the mobile equipment entered a zone that wouldn't typically be, or it is actually restricted, but potentially the operator, there's an operator error involved. So we also know that for other controls like your high vis equipment and your personal protective equipment, it gets dirty. It can be difficult to see in certain conditions. People might actually forget to wear it. There's a whole host of reasons why these barriers won't perform as expected when needed. And we call those degradation factors. So we have degradation factor controls here, which are basically barriers for your barriers, if you will. So those are the additional measures that you need to have in place to improve the reliability of those controls. It could include things like refresher training, auditing, supervision, redundant equipment, those types of those examples. So that's on the left-hand side, but really the same applies just to the right-hand side here with mitigation barriers. So if the top event were to occur like a struck by incident, some mitigation barriers that we might have in play to prevent the outcomes, the negative outcomes. There's going to be measures like first aid, emergency response, those, again, those examples. So in this research, we're really looking at ways to get folks and really identify how to start conscious discussion and conscious consideration around changing the way that sites are configured, sites are run, and the way that we're doing things in order to ultimately leverage design changes and inherently safer design. So We developed an inherently safer design workshop approach, and this really looks at identifying the hazard in your plant. So in this case, a mobile equipment in a given area, brainstorming potential ISD options and opportunities around that, and ultimately discussing the feasibility of ISD options. So one of the important notes with inherently safer design is that the most benefit can be leveraged when at design stages. So I would encourage you, anyone on the call, if you're looking at building a new facility, leasing a new space, procuring a new area that you would actually perform the work, those are the prime times to be considering inherently safer design. The less retrofitting that you have to do, obviously economically is the best. But that being said, there are still plenty of opportunities to explore ISD during the operating life cycle, if you will, in built plants. It's just you might be restricted a little bit more. Things might not be as practical or feasible, but it's still important to note that. And you just never know. Like when we're going through an ISD workshop, you should record any and all ideas and discussion points because you never know what could change down the road where something was once impractical and not feasible could actually become feasible. So it's always important to document your options. So for the mobile equipment research project that we undertook, it involved a series of workshops. So both the bow tie analysis workshops, and we combined those with the inherently safer design workshop. So they took place virtual and in person in Q4 2023. For these workshops, it was critical to have a mix of subject matter experts attend. So that include a mix of frontline personnel, safety resources, facility managers, as well as equipment suppliers, which actually were shed a lot of light and a lot of insight into some of the issues, as well as maybe some of the direction and some changes that they could actually make as suppliers. So that was very, very interesting to see. Approximately 15 individuals participated. And not only, obviously, will the individuals have the opportunity to get the final report, as will everyone, involved with the BC Forest Safety Council, and the research project was completed in conjunction with WorkSafe BC as well. So I'm sure that the subject matter experts there who receive it will share it as need be as well. So not only do they have access to those resources from the research project, they will have access to them. The workshops were very collaborative, open discussion, lots of brainstorming. So it really gave that avenue for all the attendees to collaborate with others, collaborate with their colleagues who are dealing with similar issues. But share those different perspectives around good things that they're doing, challenges that they're having. And I think there were some really good key real-time takeaways that folks were actually able to take from that. So we were very pleased and we got a lot of positive feedback on the workshops. So we completed a bow tie analysis for the musculoskeletal injuries. And so this is just an excerpt of the results of that because they can get very large. So the MSI and MSI was the top event. The hazard that we were looking at that was actually in scope of the research project was mobile equipment and warehousing, terminal operations, and pellet plant operations, because we did have a representative there from pellet plants. So something that could cause an MSI. So we're looking at threats now. Driving backwards, that can lead to neck and shoulder injuries, entering and exiting the machine frequently, repetitive activities during maintenance and technical support, adjusting the width of forks if it's not automatic, as well as extended periods of time sitting in the seats, specifically if those are lacking proper lumbar support. We identified a number of barriers. So actually, for driving backwards, considering on a case-by-case basis, if we can actually change the way that the equipment's being operated to reduce the need for backing up. Another good takeaway was using an alternate design of seat, which would be a swivel seat to actually prevent rotation. So again, looking at how we can change the design of things to reduce those threats from becoming those MSIs. For the Mobile Equipment Pedestrian Interface, or MEPI, this is again another excerpt. So what we saw a lot was that congestion is an ongoing challenge. So, folks with facilities that have very small footprints, um, and as operations and demands and workflows have changed on site, it's been hard to properly manage those change. So management of change came up actually a lot in the discussion as well. So a couple of different threats. I just mentioned the congestion. Uh, some other specific examples would be employees crossing pathways during shift change, side loading and unloading activities, and one that's important to note that was it was scope adjacent, we'll say, was that pedestrians being in walkways with the potential of actually being struck by falling inventory or stock. So like I said, that can be a consequence of some instances if, the mobile equipment strikes storage infrastructure. It can lead to that domino effect. And I do actually want to mention as well that just in the interest of time and scope, the consequences here on the right-hand side, I don't want to glaze over those. Harm to personnel, that more of that data will be entered later, but we didn't look extensively or spend a great deal of workshop time looking at the consequences because really we are trying to prevent these MSIs and prevent these struck by incidents. So there will be data input in that final report. It's just not in the excerpt here. But again, it will be fairly high level because we're really focusing on the prevention side of the bow tie. So let's go through some of the results that we had for the ISD workshop. So this is an excerpt from, excuse me, just water. This was from a traffic management plan for one of the participants. So this is something, depending on where you are at with your facility in terms of the maturity for managing mobile equipment hazards. This is a great place to start. Just color coding out areas that are no-go or restricted or very high mobile equipment areas. Yellow areas being it's a bit lighter, but you still there are potential interactions. And then we have the green zones as well. So those are a little safer. Maybe those are areas that personnel, they may or may not be required to wear high vis, whatever it might be, or maybe those are areas that heavy duty mobile equipment isn't. So this is a good starting point to get a better lay of the land for where you're at with your mobile equipment risk. But when we were looking at this and this overhead view, one of the ISD options that came out of it was actually looking at, can we actually swap where the mechanic and the office personnel park and where the mobile operators park? So if my memory serves me correctly, the square kind of in the middle of the photo, that was the mechanic and office personnel, and the mobile equipment operators were on the bottom corner. What had come up with that though was that the mechanics actually arrive early in the morning when there's less traffic. So even though the mechanics have to travel further, it's during a time where there isn't a lot of traffic. So it may or may not bring a lot of benefit in terms of risk reduction. This is another great example. So again, and this is in, I should explain, this is in a general warehousing type of scenario. So what we're looking at here is a lot of large container traffic in and out of the site. Here on the left-hand side, is where there would be pedestrians kind of starting to enter the facility or enter, sorry, the roadway. So, and then you have traffic, the truck traffic coming in and out, kind of in the same general vicinity. So, some options that came up were considering the option to create an express lane, and that was namely here on the right-hand side. And that was just to if there was truck traffic that would be able to proceed through, um, where in contrast to other truck traffic that actually had to stop and there'd be people actually getting in and out of those vehicles. If you have an express lane, that would actually reduce congestion and have, fewer vehicles around mobile equipment. Improving the separation of the traffic entering and exiting the site, improving the access control, and that's specifically here on the left-hand side, to create a formalized place that pedestrians would stop and then have a controlled release into the walkway. And that could also involve installing a stoplight and a pedestrian activated crossing light or gate. Furthermore, for this specific site, so what we saw here was that, this sign on the right-hand side, A1 to A38, it doesn't stand out very well, actually. It blends in very well to the containers. And then we also have some congestion being created here on the left-hand side from containers that are not needed. So some suggestions and some ISD options that came out of that were actually to improve the signage to make it more obvious to personnel. And then again, address this congestion on the left-hand side by removing unnecessary equipment to reduce congestion. So we have, the example of simplification here on the right-hand side with that signage, and minimization by removing the congestion. Here's another good example. So reviewing and improving the signage. So you have to consider, what I would encourage you to do on site is actually consider, is the signage clear to the audience? Can it actually be seen by drivers? And is it, clear and understandable? Because there was a question even around the interpretation of some of this. The block wheels, specifically, the sign came up as not easily understood by personnel in the workshop. And then these stairs here on the right-hand side that I'll highlight. So review, features like this and consider if they actually have a work purpose or if they're actually no longer needed and potentially posing further hazard. So that's what the question was. Consider removing the stairs. Are they actually encouraging shortcuts and posing additional hazards? So some of the workshop findings, we need to increase the awareness of new safety features that are actually available on mobile equipment. So this was an interesting point that came up, was that there are new safety features available, but the end user, unfortunately, aren't that information isn't trickling down to them for one reason or the other. So there's an opportunity for suppliers to actually spread the knowledge around that more. Like I mentioned, when you are looking at procuring facilities, whether you're starting new leases or purchasing a greenfield, and as well purchasing the mobile equipment, these are key opportunities to consider inherently safer design. So, especially with the musculoskeletal injuries, the design of that equipment will play a very big role in that. Whether it has the swivel seats, even the recessed stairs, in terms of making it easy or more secure to enter and exit mobile equipment. Um, you can't typically, as far as I know from the workshop, change the stair configuration on this mobile equipment. That is when you're buying it or leasing it. So ultimately, the key stakeholders, like the end users, the operators, and the mobile equipment staff, they need to be consulted when procuring facilities and mobile equipment. This also has to do with the movement of materials and really understanding the process on site. Again, knowing how the facility would ultimately be used, that is definitely something that has to be looked at in terms of the design for preventing these mobile equipment pedestrian interface struck by incidents. We know that leadership buy-in is key. So one of the things that we need to work on is challenging the perception that design is always more expensive than administrative controls. There's been a lot of discussion around different add-on devices and systems that can add up in terms of cost. And I'm not saying that we don't need those additional layers of protection, but like we just said, they're not 100% effective. And if we can design out interactions and potential interactions, that's the best. And lastly, poor management of change affects safety culture. So whether we are implementing new safety measures or changing the way that the work is being done on site, if changes are made and all of the potential outcomes and domino effects from those changes aren't being considered, then that will result in poor implementation and poor buy-in. So let's dive into engaging frontline workers and engaging personnel to help identify some ISD options. So the next four slides are review questions for each of the four principles of inherently safer design. So you could use these in a toolbox talk, a lunch and learn, whatever, a joint occupational health and safety meeting, whatever makes sense for you and your operation. These are just some ways that, if you're looking at, say, a near miss or an actual incident that happened on site, say, okay, instead of just, reviewing the procedure, the safe work procedure, telling everyone again how important it is to wear your personal protective equipment, this can be used as a way to actually engage folks and brainstorm and say, okay, how can we actually do something different on site? So some examples of this for minimization would be, can the hazardous equipment or activity actually be eliminated or minimized? Again, that may or may not be possible, but it's just a good question to ask. In a given activity, can the number of mobile equipment or pedestrians be reduced? A good example is, bystanders and pedestrians, can they actually be eliminated from, observing loading and unloading processes? We talked about reducing congestion. Of course, looking at blind corners. Can anything be changed about uh, whether it's the building facade, whatever it might be, to actually reduce blind corners? And ultimately, another good example of this is actually using pedestrian walkways and pedways or elevated walkways to actually separate pedestrians from mobile equipment and fully eliminate potential interactions. Uh, Again, it all depends on your facility and whether that's feasible from an economics perspective or even a physical perspective, but it's just good questions to ask and actually look at. For substitution, can we do something differently to, reduce the hazard? Can different equipment actually be used? So in some cases, can an actual hand pallet mover be used, or actually conveyor belts instead of forklifts? Different types of equipment. Another good example is when you're looking at physical limitations of personnel as they're entering and exiting buildings, um, if it's very, very bright outside and then they're entering a dark building, it takes time, obviously, for personnel's vision to adjust to that. And depending on, maybe where the pedestrian walkway is with respect to a mobile equipment pathway, maybe that's potentially like hazardous area in your facility. So can you actually reconfigure those areas? But can we also look at using different lighting configurations or types of lighting even to make that light change less of a potential risk? For moderation, can we rearrange the work site to have more separation between pedestrians and mobile equipment? Separate entrances and exits and paths, are those possible in order to actually, again, create that more of a separation distance between pedestrians and mobile equipment? Can heavy duty mobile equipment like loaders, forklifts, and tractors be separated from light duty vehicles? And you'll have Tammy is going to send with these slides after. So I know I'm cruising through them here, but you'll have access to all these following the presentation. And last but not least, simplification. So can the workplace actually be designed for human factors? So is the workplace ergonomically designed for different physical conditions of personnel? And that includes eyesight, age, mobility, walking speed. Uh, can we reduce the likelihood of personnel taking shortcuts? Are the paths configured, are designated pedestrian paths configured in such a way that, it's easy for people to understand that that's where they're supposed to walk and that they actually want to walk there, that it's the pedestrian pathway hasn't been placed in the direction of any other potential hazards, whether it's, falling objects from height, whatever it might be. It could even be things around noise, um, or chemical storage, whatever the situation might be. And let's look at engaging leadership. So some questions that we can kind of start to look at, and this really starts to tie in a bit more to the safety management system, is um, looking at senior leadership. So are they aware and knowledgeable about the hierarchy of controls and inherently safer design? Is senior leadership directing decision makers to consider inherently safer design? Is senior leadership ensuring that relevant stakeholders like mobile equipment operators and on-site staff are included in key activities like project design, procurement, risk assessments, incident investigations? And then are these subject matter experts also, knowledgeable about inherently safer design as well? And that's kind of where those review questions then can come in, right? Arrangements in place for communicating safety information to staff. And ultimately, we just need to ask ourselves, what resources and initiatives do we need to undertake to help leadership be aware of inherently safer design? For risk assessments, are engineering controls generally regarded as preferred over procedural controls? The same goes for inherently safer design. Is the hierarchy of controls and inherently safer design actually considered when looking at risk reduction measures? And then it ties in a little bit more to critical control management and these risk reduction measures. So have you actually identified which of your controls are critical? So that could be things like safe work procedures in certain cases. It can also be engineering controls like an activated gate, whatever it might be, again, kind of depending on your hazard analysis. But regardless of your critical controls, how are you ensuring the reliability and have you assigned responsibilities and accountabilities throughout your organization for these? Management of change, like I mentioned, very important. So our engineering controls generally regarded, again, even in a management of change scenario as preferred. Our ISD options considered during management of change. And really, let's look at our key personnel involved and consulted when work processes are being developed and modified on site. Equipment procurement, like I said, another really important and key opportunity to consider better design. So our key stakeholders involved, are all safety features examined and discussed? And do operators ultimately know how to select equipment that is more inherently safe for given operations and applications? It's important to note that inherently safer design is very hazard specific. So what might, a change that might work best for one operation might not for the other. So very site by site, case by case specific. And this really echoes a lot of the same points, and it just comes down to facility design and procurement and leasing. So, some closing remarks. So, we all know that mobile equipment hazards are a significant risk to personnel on site. Bow tie analysis is one tool that helps provide a better picture of the hazards on site and the controls that we need to have in place to help prevent, harm to personnel. Inherently safer design and design is the most effective and most preferred approach to risk reduction. A couple of tools like ISD review questions and self-assessments can help, start to identify ways that ISD can be integrated and implemented into facilities. And ultimately, frontline personnel and the stakeholders who are dealing with mobile equipment risk the most should be meaningfully engaged throughout decision-making processes, especially when making changes on site that will influence mobile equipment safety. And Bill, I think I did pretty good for time. We have about 15 minutes for Q&A, so I'm happy to take your questions now.
Great. That was great, Kaylee. So does anybody have any questions? Either put up your hand or send something in chat. I do have one comment though, Kaylee, is I
Yep.
do think we had a lot more people than 15 participate in all this. When you look at the starting point of the mobile equipment pedestrian interface we did with the MAG group and all the various other things that we used to help support the research. And when we got those last few groups together to that were outside of some of the earlier work that we did.
Yeah, that's a really good point, Bill. Thanks. Yeah, what did we have in the first? I think the first workshop with the sawmills was 15 to 20 alone, I think, was it?
Yeah,
Yeah, yeah.
yeah.
So
Okay,
Scott
it
has
definitely a
a
trending
question.
issue.
Yeah,
looks like Scott, you got your hand up?
Yeah, thanks,
that's
Bill, and thanks, Kaylee. Great presentation. I think one of the things that you said just in kind of your last couple slides here that I thought was definitely resonated with me in regards to the selection, of the equipment, and as we look at what is the operational need, what is the product handling requirement, all the rest of the kind of stuff. Often what we end up with is a small variety of equipment and on site that is available. And if you look at the sawmill industry, in the log yard, we might have dangle head grapplers. We'll have the traditional kind of duckbill grapple on an articulating wheel loader. We've got the big Laterno or Wagner type equipment. We've got kind of a variety of equipment out there for log handling as an example. And, I'm just kind of curious as to, even feedback from the group is how do you then train or rein in the selection of the equipment, because we have specially purposed that selection, but all of that equipment is available to the operator. And what I've recognized is that sometimes operators choose poorly, and they're using the wrong equipment for the wrong purpose for their own reasons. And just kind of wanted to throw that out there to the team while we have a little bit of time left in the session, if anybody has addressed this in an interesting way.
So Kaylee, I just wanted to add so that everybody knows that when we performed some of the later work for this research, we actually had equipment suppliers with us for mobile equipment, and we were getting I don't want to say it's conflicting results, but it seemed like they have a lot more items available for even something as simple as a forklift to help with this issue that they don't communicate out very well. And so we task them with making sure that when they are, working with operations for procurement, that they spend a bit more time making sure that the operations understand what's available for the equipment to help with these issues.
Mm. Yeah, that's a really good point, Bill. Yeah, exactly. That I touched on that ever so briefly. And yeah, it was an interesting finding for sure. Even just awareness around like backup, different kinds of like backup signals that were available, different lighting scenarios, um, seat selection, so on and so forth. But yeah, back to your question, Scott. I mean, and obviously anyone else on the call, please feel free to jump in. This is my 2 cents. It's very interesting, Scott, because as I just said, design and it's very application specific. So I understand completely why you would have, really bespoke, I'll say bespoke equipment for those applications, which in I think in a lot of respects is good design. You're picking like the most optimal equipment for that design, like for that application. Um, and this did come up actually in another workshop that we did, Scott, with in the pellet industry. Bill, you were there for that as well, where there was discussion around standardizing, a certain brand of equipment that was going to be used across the organization. So it's interesting, because in one respect, yes, it addresses, yeah, your approach, Scott, addresses the potential issues that could come up with application specific, things. But then, yeah, then you're forcing it onto the human element of, okay, well, now we're relying on the operators to do the right thing versus the other way is, okay, we're going to standardize it. So it removes that element, but then are we potentially, are there going to be circumstances that come up where that particular equipment may or may not be the best suited? Um, but that being said, it wasn't in a log handling application, Scott. So I don't think that they would have those same challenges. Um, I don't know. I'm kind of just rambling at this point. That's just like my 2 cents. I don't have a good answer for it
Mhm.
other than because I think at that point you are just relying on procedures and training. I don't know, Bill, do you have any thoughts or anyone else on the call?
Uh, the way they were talking about standardizing their equipment, I think was based on some of the biases from a few of the people that were part of the procurement
Procurement,
team.
yeah. Yeah.
While it sounds good and they're biased towards a certain machine for certain reasons,
Mm-hmm.
um, I think it lacked the collaborative approach of getting enough people involved in it to really hear everybody's point of view as to what
Mm-hmm.
makes a piece of equipment good for a certain application.
Mm-hmm. Mm-hmm.
Because I don't think they were really talking to the operators at any point.
Right, yeah. Yeah, exactly. Yeah. So, I mean, I guess, Scott, I would just flip it back to, engaging the frontline personnel, I guess understanding why would they choose, I guess, to use the other equipment and then yeah, try to address it from there, I guess. I don't know. Anyone else have any other questions or any other thoughts on that point?
Doesn't look like we're getting any other questions in, Kaylee. I'd like to thank you for the presentation. It's uh, it's a good follow-up on some of the previous presentations that we've done on the mobile equipment pedestrian interface and includes some important stuff that we found out in the later part of the process, especially when we brought in other industries into the mobile equipment bow tie, general
Yep.
warehousing, and we had some pretty large employers there, plus dock workers, all that kind of stuff.
Yeah.
So it brought in other people that sort of raised our awareness to some of the other things that we were possibly missing out on
Yeah.
in the whole process that are applicable to really all industrial sites.
Yeah,
So
exactly. Yeah, and even another good point for the terminal operation. I mean, it was great. We were so lucky to have their traffic management plan so we could actually, go through step by step. But even I would encourage you, if you're looking at your pedestrian interface, one of the things that they found out was that, they're doing a site tour, um, and they're doing it in a golf cart, correct, Bill? And
yeah,
so even just that literally like physical perspective difference between what they're seeing lower to the ground in a golf cart or a gator versus what a truck driver is seeing actually was like a very interesting finding as well. So I would encourage you, if you're doing a type of assessment around your site, try to do it from the perspective of that mobile equipment operator, from the tractor, the chip truck, whatever it might be, the skid steer. I know there's been some really good WorkSafe BC videos about blind spots and forklifts, just really how reduced that line of sight can be, and how people can travel right alongside you in your blind spot. So that was another interesting outcome as well. So, do you have anything to add on that, Bill?
Not necessarily on that. Where a lot of this is sort of connecting it for me is we recently put on a workshop for human and organizational performance, where the second half of the workshop was really all about learning teams. And so I think a lot of what we learned there applies to some of that management of change or procurement type of work. Um, and so I'm encouraged to think that we are going in the right direction in many different ways. Um, than what we had possibly looked at before. So I think we're starting to build on some of this research in to help us in other areas as well.
Yeah, agreed. Yeah, I'm really looking forward to finishing up this research project, the report, some of the resources out of it, and sharing it with everyone on the call and beyond. So, yeah, very much looking forward to that.
Yeah. Okay, that's it. I'd like to thank Kaylee, and I'd like to wish her all the best in her new position as lead engineer for industrial process safety for Jensen Hughes. There's her contact information if anybody's interested in talking to Kaylee and in her new position. And like I said right at the beginning, is the work hasn't stopped with Kaylee. We are still planning on having Kaylee help us out with things. It just means that it's a different name of company that we're hiring her through. It really is what it is. And just to remind people that we do have planned for October 8th and 10th workshops where it's a half day combustible dust and a half day on critical controls, which goes to support some of the stuff that we talked about in this presentation. So with that, thank you for participating, everybody. And Kaylee, thank you for the hard work that you have been doing for us.
Oh, my pleasure, Bill. Thanks, Tammy. Thanks, Bill. Thanks, everyone.
Okay.
Okay, bye.
Hey, goodbye.